Testing. Okay. Welcome to Programming Rainbow. In this video, we will continue on the series of the Beginner's Guide to SDL2 in C language. This is the fourth video. If you would like to follow along with this video, you can go to github.com, Programming Rainbow, and this will be called Beginner's Guide to SDL2 in C, updated. So this is the updated version. You can git clone this repository. There is some instructions for Arch Linux, by the way, and also macOS. So you can get SDL2 on your system and you can clone this repository and build it. Okay, this is the fourth video. So if you're just starting out with this video, you can just rename source directory or delete it, grab the video 3, since that was the last video, and rename it to SRC so you can follow along with where we are in this video. So let me just show you the final code. So I'm just going to use my makefile and build the final project. So it's going to be source directory. It's going to be 9 for me. Okay, so this is the final project running. So we have an image that has been drawn as the background. We have a true type font bouncing around the screen with a bubble around it. We have a loaded player sprite with a bubble around that. We can change the renderer color and we can resize the window, and it keeps the aspect ratio. Okay, and we can also play music. We have the free software song if I press M. We have the FPS, which is locked because this has an FPS module and everything's moving through delta time. We also can show the position. So we have some text modules in play that kind of deal with text for us very easily. And let's see what else. We have sound effects. So if I press N, we're going to get sound effects when it's going or when we change the background color. So this is kind of everything to get you going, moving, colliding, loading images, loading sprites, dealing with text, resizing windows, everything that you need to like make games and everything that's like that. So in the last video, let me just show you where we were. Well, I'll just build the what's in the source directory right now. Sorry, I don't need to put source there. Hold on one second. Okay, so I'll just build what was in the last video right now. So we had this window where we could change the render color, and it's also resizable. Okay, so in this video, we'll be creating the player sprite and move it around the screen. So we will be using a different way to get information about the state of the keyboard than we did in prior videos so that we can have smooth movement with our player sprite. So we've already loaded an image before with this image load texture. We've already done this before. And we did it for the background where when we drew it, I didn't pull up I should pull up the function here for that. Sorry about that. I didn't have that one ready. So when we draw this, the way that we draw the background is we have the render, we have the texture that we're drawing, and then we put null for both the source and the destination rectangles. So in this video, we are going to actually be using a destination rectangle. So the source rectangle, we'll still leave it as null. That means it's going to use the entire image as the source. So we're not taking a sub part of the image that we loaded. We're using the entire image. But then we're going to use the rectangle as the destination to decide where it gets drawn on the renderer. We can also change the size of how it's drawn on the renderer too, or the location with the X and the Y. So, and this is using SDL.rect. So let me just show you what an SDL.rect is. So an SDL.rect is just a 4 ints, an X, a Y, a width, and a height. And so we'll get this width and height actually from the image that we loaded, and we'll populate that, and then we'll use the X and the Y to move it around the screen. Okay, so since this is like a player item, I'm going to spin this off into its own module. So I'm going to make 2 new files. It's going to be player H and player C. So over here, player.h and player.c. And we need the include guards here. So we'll say if in def player H, we're going to define and then end if. Okay, and we'll pull in main. Okay, and we want to hold this what we need kind of the player. So the player has a rectangle that we know we need, at least for the destination, and it has a texture. It's also going to have some other properties. So let's just start with those things. We know we need those things, so let's start there. So I'm just going to create a rect and call it player. So the 2 fields we need is, we also need to pass in the renderer as well. So because if this wants to draw itself, it needs a pointer to the renderer. So if we drew this in game, we could just use the game renderer. But since I want to tell this player to draw itself, I'm going to copy the pointer of the game render into this one. So I'm going to be holding a copy of the pointer here. It's just another copy of the same pointer, really. So I'm going to have the render, a texture, and a rect, at least to start with. So SDL render. And then we have the texture, which is an SDL texture. This is the actual image that we're going to load. I'm going to call it image. The player only has one image. And then we have this SDL rect. And this is not a pointer. This is just actually a rect, which is just a struct of 4 ints. So I'm just going to call this rect. And that should be okay for right now. We need to put a semicolon at the end of this. I always forget that. And we're going to have some functions here. Well, we know we're going to have some. So I'm going to instance this on the heap. So we're going to have a new and a free. So I can just make those right now. I know I'm going to be passing in the render, definitely. I could also pass in the name of the image that I'm loading to. Yeah, I didn't do that before, but I can do that here. And so free is going to basically free the thing. So free will be void. So we'll do void, we'll say player free. And we just need a pointer to the player. So it'll be struct player p. If you don't want to write struct over and over, I'm doing this for, hello, how's it going? I'm being explicit about this because I'm assuming maybe people watching this are starting out in C. And also it just I know from looking at it, it's a struct, but you can also type def it. So I could say type def like this, and then I could say player here, right? And what this does is it is going to make a struct called player, which is still here. This is happening here. Sorry, semicolon here. So what this is doing is this is still doing everything that the struct was right here, but then wrapping around that, I'm type defing it with player. So this is giving me 2 things. It's giving me a struct called player, and it's giving me a new type called player. So actually, I could remove this name here. This is going to complain, but I could do this. Right? So this type def, the struct is like anonymous. It has no name. But then at the end of it, I'm calling this whole thing player. So that's different than a struct. If I wanted to keep using the word struct and use it both ways, I could add that name back in here, player. So yeah, so that I would now be able to use it 2 different ways. I can use struct player or just player. I know it's a little bit confusing, but it's kind of like 2 commands in one. This type def is wrapping around this thing. It's basically saying, hey, all of this, type def this block as player. And that's going to be a new type now. And so that this block doesn't even need the name player in it. It can be anonymous. And I won't have that ability to use the word struct now if I did that with removing the player. But since I also have the player in here, you could do it both ways. I'm going to be explicit about it, so I'm not going to type def it. But that's something you'll see and you might want to use, for simplicity. So I'm just going to be explicit about it. And I also want to return, I want to create a player that returns a player. So, or, I want to use a function that returns a player. So it'll be struct player, and this will be player new. And we know we need the render in here. So I'm going to say SDL render. And we can also pass in the name of the image. I didn't do that before, but it sounds like a good thing that we could do, and it'd make it more where you can be more general with this, and you could make other players or something, or you could name this something else and use it over and over again. So let's just pass in the name of the image that we're loading. So since we're going to pass in a string, I'm going to use the const char star, and we'll call this a file name. So this will be the file name of the actual image that we want to load. So I think I baked it in. Like if I look at my other version here, let's go down to video 4, player. So I'm baking it in directly right here, which is like a magic number where if we put it now as something we pass in, we could keep using this so we can make many of them. We could give it a more generic name than player, and then we could use it over and over again to make more objects. So I'm still going to leave it as player, but I'm going to instead pass in this string. Seems like it's a better way to do things. Just close that. So we know we need the render, and we need basically a string. Put the semicolon here, and those will be the two functions. So I'm just going to copy these and save this file, and then go into player and include the player. And we can just put these two functions in here. So for freeing, we know right away we have the render, and so I'm just going to put things in the freeing thing as we build up. So we know right away we're going to be dealing with the render. However, we don't own the render. The render is owned by game. So I want to nullify the render, but I don't want to free the render because game is going to free the render. So this is just kind of like a shared pointer or something like that. I'm sharing a pointer that the game is also using. So it's not really my pointer. So I'm going to say if, and we're passing this in as p. So it's if p is not null, right? And then I'm going to say, I don't even need to check if render is null or not, because I'm not going to free it. I'm literally just setting it to null. So I'm just going to set it to null. It doesn't matter. If it's null, it's going to be null now. If it wasn't null, no matter what happens, this command will work because I'm not actually trying to free anything. So I'm going to just set the renderer to null. That is going to be one of my cleanup steps. There will be more. And I'll say puts player free. Okay, and we'll be adding more to that. So for this struct or this function down here, and this is void, so it returns nothing. So this one right here, I want to heap allocate a player, and I'm going to use calloc just like we did with the game, because I want to make sure that I don't have latent data, data that's already in there, garbage data. I want it to be zeroed out. Okay, so I'm going to say struct player p equals calloc, and this takes how many of these I want, which I only want one, and then the size of. So the size of a struct player. And again, if you type def this, you don't need struct. You could just put player everywhere here. Okay, so, and then we need to check to see if this actually calloced it or not. So I just check if p, and we could do it two different ways. We can do it like this. We can say bang p, right, like that. But I'm going to be more explicit about it. So I'm going to say p equals null. But the other way is totally valid, and there's nothing wrong with it at all. I'm just doing that to be very explicit about everything I'm doing. So that basically, if this fails, this pointer will be null still. or it'll return a null pointer if it fails. And the bang does the exact, it's equivalent code for here. So I want to printf. This is file print formatted, and standard error is where it's going to. We'll say error in calloc of new player. And we'll put a new line character on that. This is not an SDL error, so I'm not going to do anything like that. And I need to return a player from here, so I'm going to return null. I know I could return P as well because P is null, but I just feel better by actually returning null. So if something went wrong, I'm giving myself an error message and returning null. And I'm going to be, when I instance this, I'm going to check if it's null or not to see if I'm shutting down. So now that we know we have P, I can set the render that I passed in, right? So I could say P render is equal to render. So I'm storing that right away. And now I want an image. So we already know how to do this. I don't know why I have that there. This image load texture, and we've already done this before. It takes in a render, it takes in the string, which we called file name, and it returns a pointer to an SDL texture. If it fails, it returns a null pointer. So we're checking null on that. So I'm just going to grab the code that we already did this to, because this is already in for the background, right? In load media. We've already done this exact thing right here. So I'm just going to yank this. It's going to just be a version of that, and put it here. Okay, but this is not going in G background. This is going to go in P image. It's in the player's image. So P image, and the string that we're using is going to be the string that we passed in, file name. This right here, we're going to pass something into this function, so that's what that's going to be. Okay, and then we're checking to see, and again, we could just put a bang on this, but I'm being explicit about, I'm saying if it is equal to null. Okay, so we can say error loading, I'm going to say player texture, and maybe I'll change the other one to say background. So this right here is P render, and this right here is also P render. Now, if this was successful, it needs to return P. So return P is the happy path. I was just remembering something else. I'll have to swing back around to it in a second. So right here, if this fails, we're returning null. If this fails here, we have already instanced a player. So now we have a problem. So I am going to return null, but we need to clean up the player first. And right now I know it's just here, so I can literally free it, but I've made this function that deals with it as well. So I could put just free P right here. I could do that, or I could call this function. Since I don't know if I'm ever going to put other code above here that does other things before this runs, I'm going to call this function. That's my player cleanup function, so I'm going to do that. So I'm going to say player free, put the P in there, and since I've freed the player, which is P, that's heap allocated and it's got other stuff inside of it, I need to set P to null. I know I'm exiting this function anyway, but there could be some change in your code later on where you put something else in and you got that dangling pointer. So the problem is the code up here, we are not freeing P. You know, we go into player and we set render to null, but we don't free anything. So let's, we know P exists, so we'll say free P, and then we'll set P to null. I know, again, this is a local, but I could add some more code down here, and then I have a dangling pointer. So I'm going to do that. Okay, so this is now setting the renderer to null. We also have this image that may be loaded too, if this is successful. So let's deal with that image. So we don't know if the image is loaded or not. So we need to check to make sure. So put an if P image. And the way we destroy images, we've already seen this, is that we use SDL destroy image. Destroy texture, sorry. So this will be p image. And again, we're setting this to null. Okay, so this will work if we have an image or even if we don't have an image because we're checking. Okay, so that is still a good cleanup for the player. So we have this image loaded, but we haven't dealt with the problem that we need a rectangle. Because if we were to display this right now on the screen, it will be stretched. And we saw that in the last video where this C logo was stretched every way. We want it to actually be drawn correctly, so we need that destination rectangle. So basically, we need to know the width and the height. So we have another function here. So since we're dealing with the texture, if we were dealing with a surface, we could get the width and the height directly out of it, but we're dealing with the texture, we're going to use SDL query texture. And this one can give us different information, and we don't actually care about all the information. So for the format and for the access, since we don't care about those, we're going to put null in there, and it'll just not do anything. And for these, we're going to send in the address of a number that we want this function to change. So it's width and height. So we can actually just send in the address of our rect width and our rect height, and then this function will populate those numbers for us. And this can fail. If it fails, it returns 0 on failure. Yep. So I'm just going to grab this. Okay, and we're going to wrap this in an if statement. That's 0 on failure. Sorry, 0 on success, some other number in failure. So if it gives us any number, it failed. So we'll wrap it like that. The texture here is p image. Okay, and then for format and access, we're going to use null on both of those because we don't need them. Now we have already inside player, we have this player rect that we put on the, it's in the header. So we have this rect, and rect inside of it has a .x, .y, .w, and .h, x, y, width, and height. So we're going to send in the address to the width and the height. So right here, see it says pointer to w, pointer to, so that's what we're sending in. These are ints. SDL recs are also ints, so this will work. So what we need is we need p rect.w, but we need the address of it. So we're going to send in the address like that. P rect.w, and we'll send in that as well as the address. So those will populate the rectangle directly, or the width and the height of the rectangle directly from this image. And if it fails, we'll give it some message. I'm going to do this exact same thing here. If it fails, I'm going to free the player, set the player to null, return null. So I'm just going to yank this because that means the player wasn't created correctly. So our error message will be querying texture, error, query. I think I spelled that right. And this is not an image error. This is an SDL error. Right there, up there is an image error. Okay, so if this fails, we are giving this message. We are freeing the player. We're setting p to null, and we're returning null. Okay, looking good so far. So let's just see if this is if this is going to be enough to work. So the last thing we need to do is return p. So hopefully this is all correct so far. We don't need to do anything about cleaning up a rect. A rect is not a pointer. It's not heap allocated. It's just a struct of 4 ints. So we don't need to do anything about that, but we can tell the player to draw itself. So we're going to do that. So I'm going to say this will be a void because we're not checking error on this one. So it'll be player draw, and we need a pointer to the player. So struct player p. And the way that we're going to draw the player is the way that we are drawing the background. It's the exact same. So if we go into game And this render copy right here, this looks really good. We've already seen this function before, so I'm not really going to explain it too much. It just does what it says on the tin. So it'll be p render, and the image will be p image. Now, our source rectangle is going to be still null, so we want to use the entirety of what we loaded. If you have a sprite sheet, you'll want to use sections of a sprite sheet is an image with a whole bunch of different player images inside that one image. But we're not doing that. We're just loading one image, so the source rectangle is null, but the destination rectangle does matter, and that's the one that we have created. So, and I believe, do we need to send the address? I think we need to send the address in. Let's check it. Yes, we need to send the address of it. So it'll be p rect, and it's going to be the address of this. It's a little bit more efficient because otherwise you're sending in 4 32-bit numbers versus one address. And I think an address is, 4 4-byte numbers versus one 8-byte number, I believe. It depends on what system you're on, but I think the address is 8 bytes here, so 64-bit. So this should be able to draw itself, and there's no error. So I'm going to grab this function and put it into the header because it needs to be seen by game. Okay, so this is everything. So let's link it up with game now. So in game H, I'm going to put something called player here. I'm going to add it in here. And now player is already including main H, so I can actually remove that one. It's redundant. It doesn't need to be there. So this will be struct player, something like that, yeah. So we've added that player in. So we go to game, and where we're creating the new game object right here, we've initialized SDL, we are loading the image, and now we are going to instance the player. So the player is returning a pointer. So what we can do is we can say g player equals player new, and we need to send in the render and that string. So it'll be g render, and the string is where the image that we need to load in, which is actually the C logo. That's what I'm using. So if we look in images, it's called C logo with a capital C. So images, C logo.png. So this is the way we're instancing the player. The player is going to take in the render and the image and do what it needs to do. But we need to make sure that this hasn't failed. So we're going to check the pointer on it. So we say if gPlayer is, like if it's null, or we could have put a bang on it as well. That'll work. So if it is null, we are going to do game free. Something went wrong here. So we're going to free the game. We're going to set the game to null. And we're going to return, because remember, we're in the function that is the new game function. So we're going to return null from here. We don't need to print an error message because the error has happened inside of this function somewhere, and we're already printing the error messages for whatever error occurred there. We're just propagating that error down the line. So, we're collapsing the functions down. So if this return null, this is going to free itself, and game is going to return null. And now in the main function, game wasn't even created correctly, and it's going to exit out. It's already going to be freed and exit out. So we're doing that. That gives us our player. We need to free the player. So up here, I'm going to put, since it's like last in, first out, I'm going to say if gPlayer. So if that is a pointer that's been allocated, I'm going to say player free gPlayer, since that's a function we've already created. And we're going to set this player to null. Okay, so that's going to free the player. So we're creating the player, freeing the player, but we're not drawing the player. So down here, and it's important what order this happens in. It's back to front. So whatever's on top is in the back. And as we go down, so this is the background image that's being drawn. So we want to draw our player on top of the background image. So underneath that, I'm going to say player, draw, and it's G player. And that's all I should have to do there. It should be linked up. So let's try it. Okay, so I don't see the player, so that's a bit concerning. Maybe I forgot a step. I am in that folder. I did build the correct thing. Yes, okay. So draw. Let's just spell this wrong just to see an error. Okay, so we know the image is being loaded. So in player new, we are setting aside memory for the player. We're setting the render to the render. Do we pass in the render? We did, right? So setting the render to the render. We are loading the image. We are getting the width. Oh, we're getting the width and the width, not the width and the height. That's probably why. It's probably drawing. It's just we can't see anything. Okay, there it is. Now we can't move it. I have no controls over it, but it is being drawn right there in the corner. So that is our player image. So now let's get into how we can move it. So we've been using the event to get keys right here. So this is we're pulling events, and this will get us things like if we pressed a key from going from up to down, or if we take a key from down to up. And if you have the repeating sequences too, you can kind of get like a key repeating. Let me just show you what I mean up here. So if I type the M key, I'll get one M, and then after a second or half a second, I'll start getting more M's. Okay, so yeah, but that's not what we want to happen in our game at all. We don't want movement to stutter once and then start jerking, moving. We want to know every single frame is the key in the down state. So that's not an event. That's a state of the key. So this isn't going to work for us for moving the player around. So we're going to use something else. So here we're going to get the keyboard state. It says gets a snapshot of the current keyboard state. It's not really true. It's a bad description because what we're really doing is we're getting a pointer to the SDL internal array of the keyboard state. So we don't need we're not getting a snapshot. We're just getting what the internal pointer is. We don't need to manage this at all. So whatever SDL is doing under the hood, we can keep querying this same pointer over and over again. So again, I feel like this is a very poor description because it's not a snapshot. It's an array. We're getting a pointer back to an array, the internal array of the keyboard state. It would be more interesting. So, or more accurate. So what this is an array of uint8s. And they're really just ones and zeros. This in SDL3 is bools, but here it's a uint8s. So I'm going to set this up here. And if we put a number in here, it'll actually return to us how large this array is. The array is 512, I believe. You can just look at it. It's going to be it can't be bigger than that because that's all that's the size of the struct that they've used. But we don't need to put anything here. We're just going to put null here. So if it's non-null, it's going to return something. It's going to return this populated. But if it's null, we don't care about it. What we really care about is the pointer to that array. Hello. How's it going? So I'm going to hold this pointer to the array in the player itself, and then we're going to use that to find out if what keys we want were pressed down, and we can use them, and we can use scan codes. So we're going to index this array with the scan code, and that's going to tell us if that key is in the down state during this frame or not. So that's what we're going to do. And this is a const. This is a, yeah. So I'm just going to do this right here. I don't know how to say it. I always say the things backwards, so I don't want to say it. But in player, whoop, that's not what I want to do at all. Over here, in player, watching your original series, nice. Yeah, a lot of people watching it, so I wanted to redo it so I had better information, so it's more helpful to people. And some of the design decisions I made in the original one, wasn't really happy with. So here we do need this. We're going to hold on to this pointer here, but this is not memory managed by us. This is the pointer to something that SDL is doing internally. So we will have a pointer, but we don't need to delete it or anything like that. It's not managed by us. Let's see here. So I'm just going to put this here for a second because I really just want this, right? I'm going to call it key state. So that hopefully should work. I'm going to put this over here on this side. So we have this key state. And so to get that pointer in the function down here, right before we return, I'm just going to use it to populate. So p key state equals, and this is going to be null again. Now, if it was getting a snapshot, we would have to do this every frame, but we do not have to do this every time. I'm going to set it one time, and we can query it as much as we want every single frame, and we're going to get the state of the key during that frame. Yeah, I saw them. I tried to reply to all the comments and stuff, but yeah, basically a lot of it was this thing about SDL functions return 0 if they succeed, and a number if they fail. And in C, 0 is false, and any number is true. So like this statement right here is if this is true, it's failed. So when I set the design up for that series, I tried to follow what SDL was doing. So if a function returned true, it failed, and if a function returned false, it was good. And it feels backwards, but it's also following with what SDL was doing, which is also backwards. So it's funny because SDL3 does not do that at all either. So, but it always felt funny to me. I did it, and then I was like, I shouldn't have done this. And it's just confusing to people. So also the way I kind of like heap allocated some of the stuff, or I stack allocated part of it. I didn't really like the way I was setting things up. So I wanted to, in this one, there's a lot more stuff going on. Resizing, and when we get into the text, it's going to be much nicer. It's going to be where you do the text one time and you can just make as many text objects as you want. And it's going to be very easy to deal with them and to update them and change their colors or sizes or move them around, things like that. So key state. I'm confusing. I tend to use it. Yeah, but in C, anything that's 0 is false, and any number is true. So with this function right here, it doesn't make sense because this thing is saying if it's true, it's failed. It's backwards. But again, in SDL3, this is actually backwards. I would need to put a bang here for it to work the same way. I also changed the way where I am returning a player object. I'm just going to only return it if it's fully complete. Whereas the other one, I would pass in a pointer to it and return a bool if it failed. But I'm not sure if I did that in that series or not. Okay, so we have this key state. Let me save this. Hopefully I didn't make any mistakes there on accident. So what we want to do is we want to be able to update the player, and we want to use this key state to index into it. So where is this? This is player new. So I'm going to do an update here. And this will be struct player P. And the way that we can use this now is just an array. So we're going to index it it says we can index it with scan codes down here. We go over here to scan codes, and they are basically, a space, and the arrow keys are left, right, up, down. You can look through them. You see them here. So we're just going to use all that. And I can't remember if I used if statements or a switch statement. Let me check, see if I used if or switch on my original. So I used if. Oh, yeah, I know why I did that too. Okay. So go back into player. So I could say if, and I'll say p key state, and I want to index this key state now. So imagine this is a state of all the keys, not if they've are gone from up to down or down to up, but just what are they in. So if they're down, they're going to be ones, and if they're up, they're going to be zeros. So I can say SDL scan code, right? And I could say, if I want to see if I'm moving right, I could say, well, I'm going to do ASWD. So I can say A right here. So if this is true, if it's an A, I want to move the thing to the left, right? Okay, so let's just do that. Let's do A and D real quick and see how that works. So I have the rectangle, right? So I can literally just move the X with the rectangle. So if I did press A, I want the thing to move to the left. That means I need the rect to go into a negative direction. And I need a velocity. So what I'm going to do here is in main, I'm going to put a player velocity. And I'll say it's 5. Later on, we're going to do delta time. So, but for right now, this is just a simple thing. It's just going to move 5 per frame. Okay, so we can say p rect dot x, and we'll say minus equals player velocity. And now I want to do a separate if on if it's D. The reason why I'm not going to do an else if is because I want to know if you press both keys at the same time. If I were to say, let me just copy this and I'll show you. So I have an else if here, and we'll say D on this one. So if we're using ASWD, and we'll say plus on this guy. Okay, that function is probably good enough. I'm just going to put this in the header so we can call it from game. Semicolon on that, and then we can call it in game. Game, we don't even have an update function yet, so we're going to have to create one. So above draw, below events, let's make a game function. And then we'll say player date, G player, oops, player. Okay. So that's there. We need to forward declare this, and it's going to did I not call it player update? I spelled update wrong. We're going to call it from here. It's going to go events, update, and then draw. That'll just be G there. And we're going to forward declare it at the top. So it's between events and draw. It'll be better later because we'll have more stuff in there, but let's see what happens now. So we should be able to go left and right now. And we can't, so I've done something wrong. Oh, sorry, I'm pressing the arrow keys. It does work. I'm sitting here pressing left and right arrow keys instead of A and D. So I have A and D, and if I press A and D at the same time, it shouldn't move, right? But it moves left. That's because I used the if else. So I'm going to put them in separate ifs. So if you're pressing both directions at the same time, it does not, it won't move because it actually moves twice, which means it doesn't move at all. Okay, so, and then we can just make this even better by instead of just the ASWD, we could say, I'm going to put an OR here, a logical OR, and we could paste it in again. And we could say A is the same as saying left on the arrow key. So now we have two options. If this one or this one is true, it's going to do this. And this will be right. Okay, so let's do the same thing for the Y. I'm just going to yank these. And so this one is, it's supposed to be A, S, W, D. Okay, so if it's A, S, W, D, that's left, down, up, right. Okay. So for A, we're still negative directions. For S, we are negative on the Y. Oh, sorry, we are positive on the Y, so that was correct. For the W, we are negative on the Y. Okay, let's just check that, make sure that is correct. So that's right, down, left, up. If I do left and right together, nothing happens. I let go of one, let go of the other. If I go up and down, nothing happens. Let go of one, let go of the other. A S W D. And if I do A and right, same thing happens. And D and left. Yeah, okay. So we have this diagonal movement, and that's faster than the normal. So it's like whenever we're going diagonal, we're going like not twice as fast, but faster. That's because it's not normalized, and I'm not going to do any fancy normalization. However, we can kind of just do a little hack. It's about, if we're going at a 45-degree angle, which is all I'm really doing here, is it's kind of a 0.707 is close, So we are going to, like I said, be using delta time later. So this is going to be a little bit more complicated, but instead of setting the actual velocity here directly, I'm going to instead set a direction as 1 or -1. And then if two things are set at once, so I'm going in a diagonal, I'm going to multiply it by 0.7. And it's not going to give us a great answer because this is going to be integer multiplication right now. In the future, we will be using floats, but for right now, it's integer. So it's, it's going to be, it's a little hack. It'll work good enough. So I'm going to call this like a normal 45 or something. Yeah. And it's just 707, and I'll put an F there. That's so it gets treated as a float, not a double. And so in the player, what I'm going to do here is I'm going to create two ints. One is going to be X direction and Y direction. Just X dir, and I'm going to set that so it's not, like I've got to initialize it. And int Y dir. Okay. And then what I'll do down here is I'll be checking. So in here, instead of moving anything, I'm going to set. So like this one will be -1, X dir equals -1, right? This one will be Y dir is 1. This one is -1. -1 equals. And this one will be X dir is 1. Yeah, something like that. Okay, so that's in there. And then what I'm going to do, I'm going to say if X dir, and I'll use a logical and Y dir. So if both of these have been set, we're moving diagonally. And I don't need these right here. So if both of them have been set, I need to move the x and the y by the velocity times that 0.7. And I'm just going to plus equal all of them because I already have a negative. I already have a sign on this. So what I'm going to say here is it's going to be player velocity. Excuse me. It'd be player velocity times normal, that normalized 45. So this will be 5 times this. Will probably end up being 3, hopefully. And that'll work. And also we need the x right? So this will give us the sign because this is either going to be 1 or -1. So this will give us the sign, and this is always positive here. So this is I'm gonna this right here. These are all ints, and this is an int, and this is a float. So I'm gonna cast this to an int. Sorry, I'm wrong. It's the other one. I got it backwards. This guy right here is the float. And normalized 45. Why is it? So what did I call it? What did I actually call it in the main? Yoink. If you cast it, it will just be 0, no? Oh, yeah. Yeah, you're definitely right. So I need to cast it afterwards. Yeah. You're right. It will be 0. Yeah, definitely. I had some other issue going on here, though. I don't think I've named this correctly or something. What did I call it? Wait. I can't see the difference in spelling here. N-O-M. I'm not really spelling this. Like I'm so bad at spelling. NORMALIZED _40. How are these two different? NORMALIZED. What? These two are different. The R. But there's an R in both. It's right here. You mean in the other? I'm looking at the wrong thing, ain't I? Yeah, I did. Okay. So bad. Okay. So yeah, you're totally right about the whole casting initially. So what I did is I wrote this for Delta time. So later on in another video, probably the last one or near the last, we're going to be switching this all over to floats and stuff like that. So we have the sign direction times the player thing times this. It's probably going to complain. Now these are untyped basically. They're just numbers. This one is an int. Oh no, sorry. This is a float. This is an int. Let's hope that it just likes that, and we just cast it to an int here. We'll just assume, and we'll see if my compiler complains about it. So this one is the y and the y direction. Yeah. So if it's not, it's the same thing. It's just we remove the normalized one. And so then we don't need to cast to an int and all this stuff because there's no float in the mix. Okay. Will contain, depending on your... Yeah, I have pretty strict compiler flags, so let's check out this one. Yep. Okay, so we're converting. So this guy is the int. This is the float. So we'll just convert that guy to a float. Now I'm wondering how I did it originally on the code before I started the video. I must have had that mistake in there where I put the int right on there and then it just ends up being 0. Let me check it. It was probably a bug right there. Okay. Oh, yeah, I did it in different order. Well, that works too. Okay. Well, I'll just do that then. So instead of all this shenanigans, we can just let these be floats and then just cast it right there as an int. We don't need to go back and forth with it. This is already an int. That should work. Okay, so, and now we're going diagonal. Hopefully it's a similar speed. Again, we're using integer, like maybe it ends up being a 3 is what I assuming. This will be better later with delta time and using floats and everything else, because what I'm going to do is I'm actually going to hold the x and the y as a float. Using delta time, all this stuff will be that, and then it'll be the rect at the end of wherever the rect is will be an int, but the actual movement of wherever the x and y is always being held as a float, so it'll be fine. But right now it's, this is like integer stuff going on, so it's not important. It was just bothering me before about the diagonal movement. So yeah, we have this. So this is kind of the way you're getting the key state, and we can use all these keys in combination, and they'll do exactly what you think they do. If you're pressing up and then also pressing D, it's going to go in a diagonal direction, up and to the right, stuff like that. Yeah. So yeah, let's just go over what we covered. I think this has all been in player so far in this one. So we have this new kind of player, I don't know what you want to call it, module, object, or something like that. It has a pointer to the render, but it is just the game's render, so we're not freeing that one. It has its own image, it has a rect, and it has a pointer to the internal SDL keyboard state. And we have these functions that we can free it. We can instance a new version, and we're passing in a file name for the image and the pointer to the render. We have an update, and we have a draw. I'm going to compile it just real quick again with the debug, just to see if I don't have a memory leak, because that would be terrible. Okay, let's just move it around a bit, and then that's good, and close it. And yeah, we got no memory leaks, hopefully. So if you want to see what my make file looks like that I've been using, it looks like this. So basically, if I'm down here and if I do a release build or a debug build, I use the strict flags. So up here, I'm using these. If I just do a normal build, I don't use the strict ones, but on a debug or a release, I'm using strict flags. If it's a release build, I'm using the optimization stuff. If it's a debug, I'm using the debugging stuff. And depending on if you're on Windows, I have no idea if this even works on Windows because I haven't ever programmed on Windows before. But supposedly this works for Windows. But if you're in Linux, I'm using fsanitizer, and it's using package config, so it works in Mac and Linux the same. It's trying to be, cross-platform and everything. It builds all them separately and then links them together. Also, it keeps track of any changes to the header files and builds whatever dependencies were, whatever files were dependent on that header file. So if I make a change to like main.h, everything depends on main.h and it'll actually rebuild everything. But if I just make a change to one C file or one header file somewhere, it's only going to recompile those changes if I don't tell it to do a clean build or something like that. So that's what the makefile looks like. No, I didn't want to change it. Stop. Yeah, this is the one I wanted to get back on. Where's the file that I made changes? There it is. So I accidentally made changes to this file. There we go. That's what I wanted to do. Okay, so the player. So we have this player, and it's not this one. It is the player. So we have a pointer to render. We have the texture. We have a rect, and we have the key state. We have these functions involved with it. So the cleanup is pretty easy. The only two things that are actually instance on the heap is the texture itself and the player struct that is on the heap as well. So those two things have to be freed if they are existing. So this is checking if the p pointer exists, and this is checking if the image pointer exists. And then we're just giving ourselves a little message at the bottom of that. If we're doing creating a new player, we need to pass in a pointer to render and the file to the image that we're going to load. We're going to calloc it so it is all zeroed out. That means all pointers are null by default. And we're going to just copy over that render pointer to hold it internally. We are loading the image, checking to see if it failed. If it did fail, we are going to free the player, set the pointer to null, and return null. If it was successful, we're getting the width and the height of the player. We're storing it directly into the width and the height of the rect. And we are getting that internal keyboard state. We're just holding onto that pointer. Again, we don't manage this at all. This is SDL. So I could free this. All right, sorry, I could free this. I could set this to null as well. Yeah, we could do that. Yeah. Let's see if it lets me. Sure. I'm just double check real quick before I do that. Okay. Yeah. So we're not managing that, so it doesn't matter to us. But we are getting a pointer, and that is updated every frame. Like it's the state of your keyboard, so we don't need to. Even though the website says it's getting a snapshot of it, it's not really. It's always the state of it. It's getting the state of it. It's getting a pointer that always holds the state of it. So here we're just using the key state with the scan codes, and we can OR them together with logical ORs, and we can get our directions here. And I just did this little hack to kind of get us our diagonal direction so that we don't seem to be going much faster on the diagonal. And it's just I didn't want to use cosine and all this stuff. It's just 0.707 is good enough. And this is integer right now, so this is a 5. This is probably calculating to a 3, something like that, if I'm not mistaken. And making sure it's an int. And it's just drawing itself the same way that the background, we've seen this before. We just put it in a function. Since it's holding on to its own render, it can just draw itself. And the way that we're linking it up into the game, we have an entry here now for the player right there. Also in main, we have a couple things. We have the player velocity and that normalized floating point number. So in game, in the new part of the game, right down here, after we've done everything else, we are using this player new function with the image string and the render, and it's returning a pointer. We're checking to make sure that pointer is not null. If it is null, we are going to free the game, so that propagates down the line. If it was good, when we clean up, we are seeing if the player is in fact a pointer. And then we're freeing that player and setting it to null. We have a game update function now that just calls the player update. And that player update, handles the movement of the player. Excuse me. The way that we are drawing it is just by calling its own function to draw itself and passing the player into that. And there's that new function down there for update. Lose. Yeah, well, so we're not even multiplying it on the on here. We're only doing it if both of these are set. So we're not even ever multiplying it by 0. So this one, we already know that both of these are 1 because this would either be 0 or this. Both of these have to be a 1 or a -1 for this logic to work. Because if xdir is 0, this will fail and it'll shortcut out. And if ydir is 0 to fail, and it'll go down to the else statement, which just applies the velocity, which is either one of them. This could be 1 or -1, and we get that 5 or -5. And if the other one is a 0, we're going to get 0. So it doesn't do anything. I'll show you the later version looks like this. It's not that much different. So the later version, when we're using delta time with the float here, it still looks the same up here. This is still the same. The logic is still the same. We just we're using, for one, we're using, sorry, we're not setting the rect directly. We're setting a float. There's an x and a y float directly on the player. We're setting those instead. So those always keep track of where the player really should be with the precision of a float. And then at each frame we're mixing, or each time it moves, it would be each frame. It mixes whatever that float is down to an int for that frame to happen, but we still have the position of the float because that's what's holding the real position. So it's pretty much all the same, except we're using this x and y float and then mixing that down at the end. But this is actually truly holding the position. Okay. And that one will, be more accurate with its movement with the 0.707 because it's now floats and stuff. Oh, and this is bubble. We're creating a bubble texture and everything else. This gets crazy with the bubble texture. My bubble stuff is weird. Let me just show this real quick before I get off. I may have shown this before. I forget what this is called. I'm going to have to look it up. Did I not? Where is it? Where is it? So I can't even pronounce this guy's name. The Bressen's circle drawing algorithm. Have you seen this one before? This is how you can draw a circle without using sine or cosine, right? And you only actually need to draw 1/8 of a circle. So let's look up this one. There's a thing on Wikipedia that has an animation that shows it off. It's really cool. So check this out. This is it? Oh no, is it not? Is it not here? Where's the one with the animation? It's midpoints. Okay, it's this. Check this out. So this is a way to draw a circle when there is no. This is just using like addition and subtraction or whatever. It's what do you call it? Yeah, it does say Bresham's midpoint circle algorithm. So this is wicked. Basically, to get bubbled around all my items, text, and everything else, I use the circle algorithm. I use the normal one, the sine, cosine one. But that's actually like slower if you're on some kind of small, device that didn't have much power. You don't need to do all that. It's not important. So you only need to draw 1/8 of a circle, and what you end up doing is drawing the inverse of that. See, they draw all at once, right? But to calculate this, this is the algorithm right here. Like we set x to 0. We have the radius. Y is the radius. D equals 3 minus 2 times radius. What is that? And then we have this going on. And just ignore the blit part. That's just me drawing, actually using this algorithm to draw something. But this is the algorithm. While y is greater or equal to x, we're going to increment x. If d is greater than 0, we're going to decrement y. If d equals d plus 4, like, this is insanity. This is just how you can draw a circle anywhere, you know. So I have the other. This is the mid. What do you call it? Polar coordinates trigonometry algorithm, whatever. So you can use either one of these, like, right. So I'll show you. So all the circles in my final project are drawn like this. So when I show you the final, let's see, source. So we're going to build the one for the 9th directory. Okay, so the SDL is true type font, but that bubble around it is just drawn by stamping the SDL as white around in a circle. So I just stamped it around in a circle and then turned it into a texture. And the same thing with the C, with this logo here. I took this logo, I use another function, like complicated thing, to turn this whole thing into a solid color, which I chose to be white, and then I stamp it around in a circle. Right? So both of these, and we can put, these are all happening in real time. Each time this is made with a surface stamped around in a circle, then turned into a texture. Every single, and I can, if I unlock the frame rate, let me do that real quick. So it's set at 60, but we can just like set it to 10,000 or something, right? Okay, so now my frame rate is like 8,000, but when I pop the other ones up, it's going to drop down because remember, it has to do all this surface drawing, right? So it's going to drop down a little bit because these are being regenerated every single time they change. If you keep telling these texts to regenerate themselves, if the text equals the last text that it was holding on to, if they're the same, it doesn't redraw itself. That's why the FPS number was so high before. But these are changing so often. Like this one never gets redrawn at all. But these do need to get redrawn every single frame, basically, that when this is moved by a floating point amount. So anyway, so this is, we're getting around 2.5 to 3.5 or something like that. So we can change the algorithm that I'm using internally to make that. So if we, let me close this. If we take this algorithm here, this is the entirety, and we go up here and we uncomment this guy. This is the standard algorithm with like sine, cosine stuff. It should do the same thing. Yeah, you can definitely pre-compute. That's if your circle is always going to be the same size. I'm not pre-computing, but yeah, definitely you can. And so this one is using the sine and cosine, which probably doesn't matter on my system. It can the what do you call it? Arithmetic units it can probably handle that just fine. But if you're on some like really low, if you're doing an Arduino or a Tiny 85 or something like that, and you're trying to draw a circle, it's not, So I was just like interested in it. Got stuck down this nerd hole learning about how to draw a circle, and later on, I started doing OpenGL. So this could probably be done way better in OpenGL than this. But to do the OpenGL, you need to set up your own render and everything like that. I may add that to the end of this series, where I switch out the SDL render for a scratch built OpenGL render, and it draws everything the same. I have to like learn a bit more. Like I already have a render up and running, a 2D and 3D render. Let me just show real quick. So I end up with 1 million projects. So here's Yellow Snow, OpenGL. So this is my game Yellow Snow, but it's using an OpenGL render. So where's the source code? Right here. And we see we have my 2D render. So instead of using the OpenGL render and my 2D texture, so instead of loading a texture, creating texture from surface and stuff like that, I'm doing it all myself in OpenGL. And the render here is OpenGL again. So instead of using SDL render, I'm using my, and the reason why it says 2D render is because I also have a 3D render. So this is the yellow snow game. If it I haven't been in this code in a little while, it should run hopefully. So yeah. So this is, and I made the screen bigger than it normally would be. Like it's blown up a little bit. So this is not using the SDL render, but using a scratch built OpenGL render. And then if we looked into this thing up here with it says cube, because it was like, how could I draw a cube in 3D? Well, I ended up going a little past a cube, but I got a 2D render and a 3D render in here. So if we say, call it cube. Oops, not that. That's not what it's called. And so we have the monkey from the Blender, the Suzanne monkey. And this is pretty cool, but I really wanted like the cartoony cell shading thing. So if I hit this button here, we got some cell shading action and we need some lines around it. And I wanted to know how to do lines around it. So then we got some lines and we can make those lines white or black, right? And to load this, I actually wrote a mesh loader from scratch as well. So this is actually like, this is just the model from Blender, but the loading of it into my project is with my own mesh loader. And this is the lower res version of the monkey. We can go even lower. So let's go here. It's Suzanne. It's in mesh, probably mesh loader here, or it's in game. I'm not sure where I called the to load. I hope I didn't still call it cube. Is it in cube? Am I calling cube Suzanne? It is. Okay. So this is low. So I have some meshes right here in models, I think. Yeah. So again, these are just straight up out of Blender. I just outputted them as object files. So there's a very low one. So let's do the very low. And I can spell very. I think that's right. Let's hope that I spelled it right. So this one is much more, like lower poly. Right. And I kind of like that. It's kind of cool art style, right? With the lower poly. And this is once you've loaded this is shader stuff to change what it looks like. It's really cool. Like you just changed the shader. But to get there, you got to go through a whole bunch of stuff that's a bit confusing. And we can do the high one. It's just called normal Suzanne. So this is the higher one, the higher quality one. So it's much smoother. So I can increase and decrease the black line. This whole making a black line, I was like trying to figure out how to do this. You can't actually do this properly in Blender. There's like hacks to do this, but it's not the real way, but you can do it in OpenGL the real way, where you actually take the mesh and you increase the size of the mesh and then you invert it. And that's how you get these black lines, like, the way that it's happening. It's like in Blender, it's like a grease pencil thing or something, because they're faking it. They're faking the shader stuff. Anyway, yeah, like I kind of went down a rabbit hole with a bunch of that stuff, and I started writing my own language called Hue, and then I started playing around with that, making games in Shell, Shell game. So if you ever wanted to do the same project but in Bash or ZSH, just because this is in Shell. So this is examples. Beginner's guide, yeah. Okay, so we need to do make C SG server. It's not clean because I was uploading it. I had to clean it because I was uploading it. Yeah, you watch this. It's going to be silly. That's just like me. I was like, can you do this? Surely you can't do it. And somebody asked me why I did this. And I was like, or why would I ever do this? And I was like, nobody should do this, but I just want to see if you could do it. You know? So this is from Bash.
ZSH.
You know?
Bash. ZSH.
Just in case you want to. Now I didn't implement bubble text here, so I just did drop shadows. But I'm getting 2,000 frames here. So, you know. This is written in, so like this is a server. This is Bash talking to a server, and the server is written in C, but the logic is written in Bash. So if you know Bash script, this is so I have some associated arrays, and I'm going to capture key inputs from the server. So when I get down into this game thing, I'm going to ask the server, I want an array back of these keys if they're pressed. So I'm asking for escape, space, F, P, and M. I'm going to hold these into arrays, and later on I can say, well, if escape was pressed, we're going to exit. If F was pressed, we're toggling this FPS value in Bash. You know, these are kind of like short if statements. And all this other stuff. If the music is playing, pause the music, you know, so on and so forth. If the directions are held, if A is held, or if left is held, you know, this is all shell script. But it's running a C server that you saw me compile initially, which is in here. And I'm talking over through the server through a pipe with the Unix name pipe, but you can use other methods too. So if you were trying to play like the Yellow Snow game, and it's Bash, and you can get like 800 frames a second. The more things that you do, it goes down. So like if you're trying to do like 400 sprite test, like this is 400 sprites on the screen at once, bouncing around the screen with delta time. And it only gets like 46 frames a second, right? And if I make I can increase the size of them and decrease and spin them if I want, make them snowmen, right? But I was seeing how fast I can communicate between C and Bash. So this is a lot of information going back and forth because I'm doing all the collision checking in Bash, but I need to ask the position from the C server of all of these. So I'm sending like thousands of requests back and forth between C and Bash.